I let my soul unwind in San Diego, taken away from the things that held me down. The happiness I lost, I finally found. She's in my mind, part of my soul. San Diego, I'll never leave.
The San Diego Corvair Club brings this instructional tape to you in the spirit of keeping our Corvairs in good running condition so they may bring us years of enjoyable and reliable service. A tune-up may not keep your hubcaps from falling off, but it can stop your car from smoking and increase gas mileage and performance. This tape will cover a tune-up on a basic Corvair motor, which we will presume is in sound condition. We will not cover turbo or 140 horsepower engines. For information on these engines, refer to your tech manual. Gasoline fumes and oil ignite easily, so the first step is to clean our motor. Any good degreaser sold in parts houses will do, and then spray with a garden hose to give us a cleaner and safer engine. Then we can see what's going on much better. Before we get started with engine tuning, let's take a moment to address the subject of safety. Some of us have known of accidents which have marred the enjoyment of Corvairing for some friend or acquaintance. Cases of injury or property loss have been reported which were preventable in one way or another. Safe practices are not so much a matter of knowledge as they are a state of mind, namely awareness. How does one describe the awareness attitude? Perhaps the analogy of freeway turnpike driving will serve. Any regular driver of the multi-lanes knows that the primary reason for even being there is to get from A to B. He knows that the vehicles on either side, ahead, and yes, even behind him, represent potential hazards to his health. Further, he is aware that the vehicles entering, those leaving, lane changes, slowdowns, bizarre behavior, road conditions, direction signs, and the timing of his own maneuvers all demand his constant attention. Distractions such as radio tuning, temperature adjustment, spilled coffee, etc., are never more important than his primary task of navigating that lump of steel, and he usually manages to retain that perspective. Hopefully, the similarity is obvious. One's safety, well-being, and preservation of property are paramount when operating in a hostile environment. Tunnel vision or focusing on a lesser priority is never justified. Perhaps one of the deterrents to the exercise of safety is the fact that, excluding the freeway, many of us do not live in a hostile world every day. If we did, our awareness might be keener. We do not, for example, conduct a tune-up of our vehicles on a daily basis. All the more reason to be cautious on those few occasions when we do. Please listen carefully to the following generic summary of some of the more critical hazards the weekend mechanic might face. Use your imagination, if you will, to apply them to your shop situation. 1. Moving tools and machinery like drills, grinders, belts, fans, gears, drive shafts, U-joint, and valve trains, etc. 2. Caustic substances like acids, strong alkalis, certain fuels, solvents, rust inhibitors, etc. 3. Volatile explosive materials like fuels, solvents, cleaners, highway flares, some metals, etc. 4. Potential energy hazards, raised or supported unstable masses, objects on inclines, chalked or not, compressed or extended springs, high voltage or high current circuits, pressurized vapor-filled vessels, etc. 5. Hot or extremely cold surfaces, materials like torches, soldering irons, exhaust system components, valve covers, chilled parts, windshield washer fluid in winter, air or refrigeration compressor fittings, etc. 6. Interrupted operations. Implausible as it may sound, that stray phone call or dinner bell can be the beginning of a deadly mistake. Re-establishing a train of thought after resuming work can be confusing. In short, don't forget what you were doing when you stopped. 7. Trip hazards. The protruding handle of the floor jack you just used, stray chocks and shorings, extension cords, oil grease deposits, and other housekeeping sins. Other dangers may be regional or seasonal in character. Many service stations in hot, dry areas refuse to pump gasoline during certain hours of summer days. Safety films of those explosive vapors climbing out of an open container and spreading throughout the area can be very convincing. Likewise, the super-cooled washer fluid previously mentioned, if it's guaranteed not to freeze at minus 40 degrees, it just might be sitting there in the reservoir at minus 38. Safety equipment itself generally provides a good return on one's money. Preventative equipment should include jack stands, the correct shop manual, safety glasses, gloves, housekeeping supplies, and lighting and ventilating appliances. Corrective equipment most certainly should include adequate numbers and types of fire extinguishers. Halon is the most universal. Eye wash, readily available ice or cold packs, critical telephone numbers, a handy floor jack, and sawdust wood shavings kitty litter for absorption. Remember those fuel spill carts located near each airport departure gate? In summary, please keep in mind that those hobbyists who live happy, healthy, and virtually accident-free lives do so by exercising awareness as a regular habit. It isn't necessary to become paranoid on the subject of safety, merely to think clearly and logically about each operation, and hopefully to stay one step ahead in planning. It may be said that gravity, like rust, never sleeps, and that Murphy's laws will apply themselves quite democratically to any and all who transgress. Become aware and remain so. Enjoy your technical endeavors and give your family and friends the opportunity to enjoy your enjoyment. Let's talk about tools. Aside from standard hand tools such as pliers, screwdrivers, etc., there are a few specialized tools that are needed. A 13/16 spark plug socket with rubber insert, a 6-inch and 8-inch drive extension, a 3/8-inch drive ratchet, a 3/4-inch box and open-end wrench, feeler gauges, both wire type for spark plugs and flat for points, a timing light, dwell meter with tachometer if possible, unisync or vacuum gauge with T-fitting and rubber hose, and white chalk. You may not have all of these tools in your toolbox, so call one of your fellow Corvair Club members or a tool rental business in your area. Let's move on to parts needed. Any good auto parts store will have the following items for your tune-up. 6 spark plugs, check your manual for the type and heat range you need, points and condenser, distributor rotor, distributor cap. Spark plug wiring set. It should be changed every other tune-up for 2 years. This item is optional. Air filters, as with the wiring set, this item should be changed every other tune-up or as condition warrants. Distributor primary wire, PN 1954563. Distributor vacuum advance arm boot, PN 1963610. Spark plug wires and spark plugs. The plug wires should be checked for continuity at every tune-up and are ordinarily changed every 2 to 3 years or 24,000 miles. Normal use causes them to deteriorate, while mishandling will damage them. Each plug should be checked by removing the connection at the plug and observing the arc between the plug connection and the wire terminal. Always wear gloves when performing this check to avoid electrical shock, taking care to keep hands clear of the fan and moving belt. The arc should be blue, about 3/8 of an inch long or longer. Careful removal and installation of the plug wires will ensure longer wire life. Do not twist or bend the wires. Remove them by grasping the rubber insulators firmly and pulling straight away from the plugs or cap. Wires with damaged connections or cracked insulation should be replaced. Pay particular attention to the large neoprene boots at the plug end of the wires. These boots must remain soft and pliable so that they will fit snugly in the shroud holes. Should they become dislodged from the shroud, blower fan air will bypass the engine and create a potential for engine overheating. Replace the wires one at a time, noting the wire length necessary to reach from the distributor to each respective plug. Note the wire routing across the shroud for cylinders 2, 4, and 6. Route wires to avoid interference with carburetor linkage. Spark plug manufacturers market different plug types. Plugs are sold by heat range as to resistor or non-resistor type. Consult your manual for heat range recommendation. Most auto parts stores have a chart giving equivalent heat range plugs in other brands. Resistor type plugs are designed to reduce radio interference. 1969 Corvairs were originally equipped with this type of plug. You may wish to try them. If this helps radio reception and does not reduce engine performance, why not? Once the plug selection has been made, the gap must be set between the tip and the electrode. Always use a wire gap gauge for this procedure, as it is very difficult to obtain an accurate gap with flat or feeler gauges. Use the adjusting tool that is normally a part of the wire gauge set. Set the gap to the manufacturer's recommendations for your particular engine. Gaps for Corvairs normally range from 0.028 to 0.035. If the gap is too large, the plug may not fire. Too close, and the performance and plug life are reduced, so make sure you get it right. Note that the connector end of the plug screws on. Make sure it is tight. Now set the gapped plugs aside. It's time to turn your attention to the removal of the old plugs. With the plug wires removed from the top shroud, loosen the plugs 2 turns. Reconnect the plug wires, start the engine, and allow to run for 3 to 4 seconds, then shut off the ignition. Use a spark plug socket, universal joint, 6-inch extension, and ratchet. The purpose of this is twofold: to blow accumulated debris away from the plug hole so it doesn't fall into the cylinder, and to loosen carbon in the combustion chamber and out through the exhaust valves. Caution: never remove plugs from a hot engine. Remember how aluminum expands when hot. Returning to the engine, remove the plug wires again and completely remove the plugs. If there is substantial resistance on their removal, stop. From the point where resistance is encountered, screw the plug in a full turn. Spray penetrating oil on the exposed threads and wait for a few minutes. The resistance is normally carbon, and the penetrating oil will soften it so no damage is done to the fragile aluminum threads in the head. Keep the plugs in order as you remove them. This will permit you to make a rough determination of each cylinder's condition. Plug charts produced by Champion and other plug manufacturers will guide you in assessing the condition of each cylinder. Now look at the threads in the old plugs. Has any of the aluminum from the head adhered to the plug threads? Using a strong light, look at the threads in the heads. You cannot see them entirely, but you should be able to see enough to ascertain that there is or is not a problem with the threads. After making sure the threaded holes are in good condition, reach in and check that there are no gaskets remaining in the plug bores. Frequently, a gasket will not come out with a plug, and the next set of plugs and gaskets goes in on top of it. When installing the new plugs, it is always best to start them by hand. If you find you cannot reach the threads, use a piece of rubber hose to extend your reach. Take care not to cross-thread the plug in its bore. If the threads are clean, you should be able to screw them in until the gasket lightly seats on the head without using a tool. Now torque the plugs to 15 foot-pounds. This has been found sufficient to compress the gasket and prevent leaks. Now replace the plug wires and boots. This part of the tune-up is now complete. Now let's look at the distributor. After many miles, a buildup of material collects on the rotor tip and cap terminals. This can be scraped off, but better to replace. Now we'll check the dust cover for cracks and splits. We will also examine the points, condenser, cam lubricator, point plate, primary wire, vacuum advance unit, and the vacuum hose for condition and proper operation. If they are found to be defective or worn, we will replace them. First, let's look at the rotor. The top spring should be held firmly in place, not worn through at the contact point, and it should sound like a spring when depressed and released. If it is cracked, loose, or if you're in doubt, replace it. If the rotor has any buildup of burnt material on it, it can be scraped off. If the rotor tip shows signs of very rough edges, it may be too short to make good contact and should be replaced. Be sure to check the tip length of the new rotor. Some brands are too short to make good contact. Now check the fit of the rotor on the distributor. If it is too loose and moves back and forth, it can change spark timing. Replace it. Now let's look at the points. First, we need to open the points and look at the contact surfaces. Due to spark action, metal can be transferred from one point to the other. This is called pitting. To remove the points, first disconnect this electrical wire. Your distributor may have either a slip-on wire connection which comes apart like this, or it may be one with a screw to hold the wire in place. Now that we have the wire off, we need to take out this screw to replace the points. A magnetic screwdriver helps to retain screw. Now lift off the points. Next, let's examine the condenser. Its wire attaches here along the primary wire and the points. If this wire insulation is stiff, cracked, or missing in spots, or is pulled out of the condenser, replace it. Now let's check the primary wire. It's connected here. The insulation should not be dried out, cracked, or chipped away anywhere along its length, especially at the coil end and the distributor entry point. Check it carefully and replace if bad or even doubtful. Remove the screw, but be careful not to lose it. An alternate method of removal is to lift the condenser while holding the screwdriver snug in the screw slot. Carefully done, this will help keep the screw from being lost. If the screw does fall down where it is difficult to reach, a magnetized screwdriver or small magnet taped to a stick or coat hanger wire can be used to retrieve it. Now we want to check the cam. The cam is the 6-sided shaft here. We want to check to be sure it moves freely on the distributor shaft. The rotor makes a good handle for moving the cam. If there is any binding or if excessive effort is needed to move the cam, repairs are required. Refer to the Distributor Service Operations in Section 6Y, Ignition Systems, in the Corvair Shop Manual for cam servicing. Having seen that the cam moves freely, we want to check the cam lobe lubricator. This is the piece of felt or sponge. It should be saturated or near so with cam lobe lube or white grease. As the cam turns, the lobe should just touch the lubricator. The next item to check is Vacuum Advanced Unit. This unit changes the spark timing at the demand of the driver's foot. If it is not working properly, less than desirable engine performance will result. This rubber boot covers the moving arm of the vacuum unit to keep out dirt and water. Remove it. We inspect it for cracks, tears, stiffness, and replace if necessary. With the boot removed, we can see the vacuum unit operating arm. It is attached to the point plate. We will disconnect these two and check them separately. A rubber hose is attached to the vacuum unit here and runs back to the carburetor here. We will remove the hose at the carburetor end, and while doing so, we will check to see if the hose fits snugly on the carburetor pipe. If it's loose, a vacuum leak can occur. Cut back 1 inch or replace it. An increase in carburetor vacuum causes the vacuum unit arm to move. We can simulate this by sucking on the hose. When suction is applied to the hose, the vacuum unit arm will be seen to move. When it is moved as far as it can, we want to hold the vacuum in the unit to check for leaks. We can do this by pinching the hose shut with pliers or putting your tongue on the end of the hose. If there is a leak in the vacuum unit, or a loose hose connection or bad hose, you will see the arm move back to its previous position. If it does, first replace the hose and recheck. If it still moves, replace the vacuum unit, but check it for leaks before installing. The final distributor item to check during a minor tune-up is the point plate. While disconnected from the vacuum unit arm, the plate should move easily back and forth. It is pivoted here and rides on plastic buttons here and here. A small dab of lobe lube or of white grease here and here completes our check of the point plate. If the point plate pivot is worn, the plate will move around and cause improper spark timing, resulting in lessened engine performance and should be replaced. We have completed our check of distributor parts and are ready for reassembly. First, reconnect the vacuum unit hose. Now connect the vacuum unit arm to the point plate. Now put on the vacuum unit arm boot. The condenser goes in next. Ignition point replacement is next. When we put in new points, we want to first inspect them. The contact surfaces should be closed completely, flat with each other all the way around, not at an angle. Now install them on the point plate. Not too tight. We have to set the point gap with a feeler gauge. Look in the manual for specs. It says 19 thousandths. Adjust the point gap with a screwdriver in this slot. First, let's open the points enough for the blade to go between them. Now we insert the blade so, and hold it so the flat sides are parallel to the point contact surfaces. Now we slowly close the points with the screwdriver and gently raise and lower the feeler gauge until we feel a slight drag, and stop closing the points. Now, letting go of the gauge, but holding the adjustment screwdriver, we take another screwdriver and tighten the point hold-down screw. Now we recheck the gap setting to be sure it did not shift. Now connect the primary wire and the condenser wire. We check the vacuum unit and hose, the vacuum unit operating arm and boot, the point plate pivot, cam lobe lubricator, cam, points, condenser, and primary wire. Next, we put the dust cap on the distributor, and now the rotor. And finally, the distributor cap. Remember, it only fits one way. Tighten the screws snugly, but remember, plastic brakes, so not too tight. Carburation. All Corvairs except the turbocharged models, Spider and Corsa, use variations of the General Motors Rochester Model H carburetor. Since all these Corvairs use two carburetors, one for each side of the engine, the primary objective of carburetor tune-up is the synchronization of the carburetors and their connecting linkage. The 1960 Corvair was unique in that the choke mechanism was not part of the carburetor. A single thermostatically controlled choke mechanism was installed within the air cleaner induction system. The 1961 Corvair was also unique in that each carburetor was equipped with a manually operated choke mechanism that was controlled by a push-pull cable operated from the instrument panel. Corvairs produced between 1962 and 1969 used identical automatic choke mechanisms that were very simple and usually reliable. The function of the choke in all Corvair installations is to block off part of the airflow into the carburetor during cold starting. In the west and southern United States, this feature of your Corvair is not overly important. However, if you do reside anywhere that the outside temperature falls below 55 to 60 degrees, your Corvair will not be easy to start without using some choking. Inherent in the choke function on all Corvairs was the means to make the engine run at a faster speed at idle when the choke was functioning. Experience has shown us that this single feature of the Corvair carburetor is probably the source of many carburetor performance problems. The cross-shaft linkage between the carburetors and the linkage between the cross-shaft in each carburetor is a relatively simple concept. However, the linkage is subject to abuse and misalignment because of its overexposed location on top of the engine. As the Corvair ages, the linkage is subject to wear at its pivot points, which allows for looseness in the various connections. A loose or badly worn cross-shaft link between the carburetors will make it nearly impossible to synchronize them. Installation. Each carburetor is mounted on the intake manifold portion of the cylinder head casing, separated by an insulator block. The insulator block, made of a plastic material, serves two purposes. First, it prevents direct heat transfer from the cylinder head to the carburetor, and second, it serves as a sealing surface between the carburetor and the cylinder head. Check to see if the insulator block is cracked and replace it if it looks suspicious. Ensure that the insulator block is installed correctly by comparing it to the bottom of the carburetor. Install the carburetor by sliding it down over the two studs extending upward from the cylinder head. Secure it with two 1/2-inch nuts and flat washers. Note that each carburetor faces in opposite directions from each other. The left side, driver's side, carburetor fuel line inlet faces toward the rear of the car. The right side carburetor fuel line inlet faces toward the front of the car. Fuel line installation to the carburetors requires care. The fuel lines and their screw fittings are made of steel. The carburetor fuel line inlet fittings are made of a soft cast metal. Thread the fuel line fittings into the carburetor inlet with your fingertips to assure that you haven't misaligned the thread connections. Slight movements of the fuel lines with one hand while threading the fittings together may help your alignment process. After you have hand-started the threads, tighten them with a 7/16-inch fuel line wrench. Do not use a regular end wrench on fuel line fittings. The wrong wrench will positively slip on the fitting and round them so a positive joint cannot be made. Many or most Corvair fuel lines have been irreparably damaged by the use of the wrong wrench. Replacement fuel lines bent to the correct specifications are available from aftermarket vendors. Never attempt to use rubber hoses as a substitute or to replace a steel line with a hand-formed copper tube. Rubber will deteriorate quickly because of engine heat, and copper will eventually fracture because of vibration. Either case will allow fuel to leak, creating an impressive fire in the engine compartment. Each carburetor has a short vertical tube that extends upward from the base of the carburetor body. The purpose of this tube is to provide a vacuum source to the spark advance mechanism attached to the distributor. The right-hand carburetor should have a vacuum advance hose connected to the vertical tube. The left side carburetor vertical tube must be capped off with a plastic plug or short piece of plugged rubber hose. The cross shaft assembly is on the mounting pads at the top of each carburetor bowl cover. It is secured with 3 machine screws and star washers at each mounting pad. Connect a throttle return spring at its attachment point on the accelerator rod by inserting the small clevis on the rod into the fitting on the cross shaft. Thread the return spring through the hole in the clevis and connect the return spring to its attachment point. The attachment point for the spring will vary because of engine models. In some cases, the spring is attached to the air cleaner support. In other cases, a separate tab was fixed to the engine shroud sheet metal. Each carburetor has a different linkage which connects it to the cross shaft. The left carburetor linkage mounts to the throttle valve lever with a retainer clip. This link incorporates a swivel. The right carburetor uses a simple rod that connects to the throttle valve lever directly and is held in place with a clip. In order to synchronize the carburetors mechanically, the linkage between the carburetors and the cross shaft must be disconnected at the cross shaft. Adjustments and synchronization. Perform the following adjustments on each carburetor in sequence with both throttle rods disconnected at the cross shaft. Choke control rods disconnected, that's 1962 through 69 models, and with the engine off. 1. Back the idle speed screw away from the throttle lever. Open the choke valve so the throttle level does not ride the fast idle cam. 2. Place a .003-inch feeler gauge between the idle speed screw and throttle lever. 3. Turn the screw until it just touches the feeler gauge. 4. Remove the feeler gauge and turn the screw 1 1/2 more turns. This adjustment sets the throttle valve at an appropriate idle speed. 5. Set the idle mixture valve by turning the idle mixture screw very lightly to its seat at the base of the carburetor. Back the screw out 1 1/2 turns. Do not turn the idle mixture screw tightly against its seat or you may damage the idle needle valve. 6. Connect the right carburetor throttle rod to the carburetor cross shaft lever using a retaining clip. 7. Grasp the accelerator rod and pull rearward to rotate the cross shaft. Observe that the right side carburetor throttle valve moves freely. 8. With the right side carburetor throttle closed, adjust the left side throttle rod length in the swivel so that the upper end of the throttle rod freely enters the hole on the carburetor cross shaft lever. Shorten the rod 1 more turn in the swivel, reinsert the cross shaft lever, and secure it in place with a clip. The carburetors are now mechanically synchronized. Any further adjustments must be made identically to both carburetors to retain mechanical synchronization. Pull the PVC out of the hose. Shake it. If it does not rattle, replace it. Start the engine and allow it to reach operating temperature. Check the timing by using a timing light. Set the timing to specifications required by your engine. Connect a tachometer to the engine. A simple tachometer dwell meter can be connected to the negative terminal of the ignition coil. The General Motors shop manual recommends the use of a vacuum gauge to fine-tune the carburetor synchronization. A faster and more positive method of fine-tuning is through the use of a unisync tool. The unisync is commonly available through automobile parts and accessory stores, or it may be ordered by mail from one of the Corvair parts suppliers throughout the country. The unisync fits directly on top of the carburetor inlet. By adjusting the unisync to indicate airflow into one carburetor, it may then be placed on the opposite carburetor. By opening or closing the idle speed screws, matching airflows can be obtained for both carburetors. The procedure is simple. The following steps should be followed. 1. With engine running at idle, observe engine speed, that's RPM, on the tachometer. Idle RPM should be 500 for 80 horsepower and 95 horsepower engines, and 600 RPM for 102 and 110 horsepower engines. 2. If necessary, set the engine idle speed to specifications by opening or closing the carburetor idle speed screw. 3. When proper idle speed is indicated on the tachometer, place the unisync on top of the inlet to either carburetor. Observe the reading on the unisync. 4. Place the unisync on the opposite carburetor. Observe the reading. If the readings are nearly identical, the carburetors are fully synchronized. If not, change the idle speed screw setting on the carburetor with the lowest unisync reading. 5. When changing the idle speed setting for either carburetor, observe engine RPM indication on the tachometer. If the idle speed is too low or too high, reset the speed by altering the idle speed screw. Several attempts may be required to achieve exact idle speed desired while simultaneously achieving identical unisync readings for each carburetor. 6. If the unisync readings cannot be made equal while achieving proper idle speed, a readjustment of the carburetor linkage may be required. Adjust the left carburetor throttle rod one turn, up to increase left carburetor vacuum and down to decrease. Recheck the unisync readings on both carburetors. Make this throttle rod adjustment by disconnecting the rod at the cross shaft and rotating it in the swivel. 7. Shut the engine off. Hold the choke valve closed, and while holding the choke control rod up against the stop in the choke thermostat bracket, adjust the choke control rod until it freely enters the hole in the choke shaft lever. Do not crank the rod by grasping its offset portion. Twist the rod with your fingertips to raise or lower it. Secure the choke rod to the choke shaft lever with a clip. 8. To adjust the fast idle feature of the carburetor, place the throttle lever on the second highest step of the fast idle cam on the choke shaft lever assembly. Bend the tang on the throttle level to obtain 78 thousandths of an inch clearance. That's .078. Repeat this for both carburetors. This step is easier to achieve if the carburetor is removed from the engine. However, with deft fingers, this adjustment is not difficult. 9. Replace the air cleaner assembly. It is very important to use a cork gasket between the carburetor inlet and the air cleaners. If this gasket is not installed, foreign material can enter the carburetor and result in engine damage. 10. Restart the engine and check for idle speed. If there is a change in speed, inspect the air cleaner assembly and replace the filter or filters if needed. A dirty filter in the air cleaner assembly will result in an improper fuel-air mixture and affect the engine performance. 11. Remove the tachometer connections. Carburetor tune-up is now complete. Common problems concerning the Corvair Model H carburetors seem to center on improper choke action and vacuum leaks at the throttle shaft where it exits the carburetor body. Vacuum leaks from any source will result in poor engine performance. Because the Corvair air-cooled engine runs hotter than an equivalent liquid-cooled engine, rubber components tend to break down sooner and need attention more often. If you suspect a vacuum leak, check the condition of the rubber hose connections at the ends of the vacuum balance tube. The connection is just beneath the forward side of each carburetor. This area of the engine generates a significant degree of heat, which shortens the life of the rubber connecting hoses. On automatic transmission cars, a vacuum hose is connected from the vacuum balance tube to the transmission. This hose can also be the source of a vacuum leak. All cars commencing in mid-1962 were equipped with variations of a positive crankcase ventilation system. This system also connects to the vacuum balance tube and can be the source of leaks. Concerning improper choke performance, the symptoms are several. If the choke is adjusted improperly, poor performance while the engine is cold will be obvious. The engine will idle roughly and emit black sooty smoke from the exhaust. If the fast idle circuit is not functioning properly, the throttle will not completely close. In this situation, idle may seem faster than normal, and when the engine ignition is shut off when the engine is warm, the engine may tend to continue running very roughly. This condition is known as dieseling. If this occurs, recheck the complete synchronization process and assure that the throttle valves close. Vacuum leaks at the throttle shaft are caused by wear in the throttle body itself. The simplest repair is to replace the carburetor. Recently, an aftermarket vendor is selling small seals that can be installed at the throttle shaft carburetor body opening. This fix requires an experienced mechanic and should not be attempted by an inexperienced person. That concludes the tune-up of your Corvair engine. The San Diego Corvair Club hopes that this tape will help you have many years of enjoyable service from your Corvair. It may be slightly difficult to carry the VCR and TV out to the car, so we have supplied a written version of this tape as well. The most effective way to utilize this tape is to watch it more than once. Then, while you're working on your car, you should be able to visualize the tape as you go. Always keep a shop manual handy for reference. Watch for the next in the series of Corvair tapes covering such items as brake repair, O-ring sealing, carburetor rebuilding, exterior restoration, interior restoration, and others. We welcome any and all comments to help us produce a better tape in the future. Thank you.
mind how soft the breezes blow. I let my soul unwind in San Diego. I lost, I finally found. She's in my mind, part of my soul. Now I belong to San Diego. I'll never leave, how could I go? Now I belong to San Diego. Just another town, a place with a name I can't remember.